All right, here's day 2 of radical review. We're going to talk about how to multiply and divide radical expressions today. So we discussed simplifying radicals. We talked about adding and subtracting radicals. Now we're going to talk about how do we multiply and divide them. So multiplication is fairly straightforward. It's just one more step than what we did with simplifying earlier. And so all we're going to do with multiplying radicals is we're going to multiply like terms. So basically coefficients, so numbers on the outside with numbers on the outside, and then the radicals with the radicals. So anything with a radical I can multiply, anything outside the radical I can multiply. So if we look at this example down below, I have the square root of 5 times the square root of 35. Both are inside radicals, so I can go ahead and multiply them together. And so that's where this 175 comes in. So if I take 5 times 35, I get 175. Now, once I get this new radical, so I combined, I need to look to reduce it if I can. And so if we kind of review our process from yesterday, if I want to break down 175, I come up to my list. I need anything less than 175, and I start testing. And so what happens is I start dividing. 169 gives me a decimal. If I take 175 divided by 144, I get a decimal, and then I keep working my way down. And what I notice is I got to work my way all the way down until I get to 25. Everything above that gives me a decimal of some kind. So when I divide by 25, I get 7 left over. So that's where that's what's happening here is I'm breaking this down into 25 and 7. And then since 25 is a perfect square, I take the square root and it becomes 5. The 7 is not a perfect square, so it stays inside the radical, and I get my final answer of 5 times the square root of 7. Now, if there are coefficients involved, so coefficients are those numbers on the outside, in that case, we only have like one little thing that we have to kind of take note of. In this particular instance, when we multiply like terms, we have the 2 and the 3 on the outside. So on the outside terms, I can multiply those together. So 2 times 3 gives me 6. And then anything inside the radical, so 8 and 7 can be combined, and so those come together and make 56. And so now I have this expression, 6 times the square root of 56. And I need to look to see if 56 will break down. And so the process we talked about yesterday was find the smaller numbers and just start dividing. So I divide by 49 and get a decimal. 36 gives a decimal. 25 gives a decimal, and I work my way down until I finally find 4. And so 56 breaks down into 4 and 14 like we see here. Since 4 is a perfect square, it comes out as the square root of 4, which is 2. And then the 14 is not a perfect square, so it stays put. And then since there was already a 6 on the outside, now I have this 6 times 2, which gives me 12. And then the square root of 14 just comes along for the ride. So when we're multiplying radical expressions, it's just multiply the numbers that are the same, or multiply the terms that are in the same spot. Outside times outside, inside times inside. And then reduce anything that comes out of that using the process from yesterday. Now, one quick thing, if you're given a radical expression where nothing's in front, so if I did like square root of 5 times 4 square roots of 7, if I were going to multiply these two terms together, my outside terms, I've got 4, and there's nothing in front of the square root of 5, so I have to make sure I understand that there's like an assumed 1 there. So 4 times 1 is 4, and then for my radicals, 5 times 7 would be 35, and then 35 doesn't break down, so I just leave it as 4 square roots of 35. So if there's nothing in front of the radical, you can assume that there's a 1 there and multiply those outside terms. Now, when we divide radicals, these are a little bit more involved depending on how the numbers that we get. So in this case, we're still going to kind of do the same process where we divide like terms. So we're going to divide everything out that we can and simplify the fraction as much as possible. And then we're going to do a process called rationalizing the denominator, and we'll see what that looks like here in a little bit. But just to kind of get you started with the dividing radicals, we have this first example here where we have the square root of 56 divided by the square root of 7. So any numbers on the outside can be divided with any numbers on the outside. So if we can divide those, we go for it. Now in this case, it's a 1 and a 1, so if I divide those, I get 1. And then I can take the inside terms, And so I got 56 and 7, and I can try to divide those out. So 56 divided by 7 in this case gives me an 8, and we're inside the radical because 56 and 7 were inside the radical. And then once I get my result, if I can break it down, I need to do so. So 8 gets broken down into 4 and 2. The square root of 4 becomes 2. The other 2 is not a perfect square, so it stays inside the radical. And so square root of 56 divided by square root of 7 gives me 2 square roots of 2. Now if we get an example like this next one here, this is where we're going to have to use some rationalizing, and we're going to talk about what that looks like here. So if I were to take these numbers and divide them right now, the outside terms, there's nothing there to divide. The inside terms, if I take 5 divided by 10, I get 1 over 2. And then I have to remember that I'm in the square root. So square root of 1 over square root of 2. Well, if I'm looking at this expression, first of all, the square root of 1 is just 1, so I can get rid of that radical there. But the other thing that we see here is that we have this square root of 2 in the bottom of my fraction, which we don't want to have. And so what's going to happen here is to get rid of that square root of 2 on the bottom, all we're going to do is we're going to take this fraction that we have here, and we're going to multiply the top and the bottom by the radical. So I already had a square root of 2, I'm going to multiply it by square root of 2. And I have to do it to top and bottom so we don't change the overall problem. So right here, I have 1 times the square root of 2, which is just square root of 2. Now on the bottom here, I have the square root of 2 times the square root of 2. When I multiply those using what we just talked about, that would give me the square root of 4. But the square root of 4 reduces down to 2, and so now I have my expression where I don't have any radicals left in the bottom and everything is simplified down as far as it can be. Okay, so let's look at some other examples here. So as far as multiplying and dividing, when we multiply, outside times outside. So 3 times 6 is 18. And then inside times inside, 3 times 6 is 18, so I've got the square root of 18. Now from here, I look to see, can I reduce my radical expression? And so I should notice that 18 can be broken down as 9 times 2. The square root of 9 is 3. And then I already had an 18 out front, so I take 18 times 3, and I get 54 square roots of 2. So once I multiply my like terms together, I go through that process again of simplifying the radical down. If I look at the next example, square root of 20 divided by square root of 5. Both terms are on the inside of a radical, so I go ahead and divide them. 20 divided by 5 is 4, so I've got the square root of 4. The square root of 4 is a perfect square though, and it just becomes 2. Now in the next example, I've got 7 divided by the square root of 3. Now first of all, 7 and 3 don't reduce anyway, but the 7 is outside and the 3 is inside the radical. They cannot be combined even if they were the same. So like if I had 8 over the square root of 2, I can't take 8 divided by 2. They're not like terms. 8's outside, 2 is inside. It doesn't work that way. So what I have to do with this one is understand that I don't want this radical in the bottom. So what I need to do is what we just talked about on the last slide. I'm going to multiply the top and the bottom by the radical in the denominator. So I'm going to multiply top and bottom by square root of 3. And so on top, 7 times square root of 3, nothing combines because one's outside, one's inside. Square root of 3 times square root of 3 becomes square root of 9. But we know that the square root of 9 is 3, and so there's my final result. So 7 square roots of 3 divided by 3. If we look at some more examples here, like the multiplication, I think you guys should have a pretty good handle on right now. Just multiply the outside, multiply the inside, reduce it out. Let's look at these division ones. So on these division ones, notice we have a square root of 6 over square root of 7. So I could try to divide those first, but 6 and 7 don't divide into each other. So I'm going to start by getting rid of the radical in the denominator. I want to get rid of that square root of 7. So to do that, I multiply the top and the bottom by the bottom number. So I'm going to multiply by square root of 7 and square root of 7. So on the top, 6 times 7 gives me square root of 42. On the bottom, square root of 7 times square root of 7 is square root of 49, which is 7. And so now when I look at this result here, I could check real quick to see if 42 reduces. So 42 divided by 25 gives me a decimal. 42 divided by 16 gives me a decimal. 42 divided by 9 gives me a decimal. And 42 divided by 4 gives me a decimal. So if I work my way down, 42 doesn't simplify, I just leave it as is. On the next one, I've got 3 over 12. Now 3 and 12 would normally reduce, but the 3 is outside and the 12 is inside, so I cannot combine them. So I'm going to get rid of that radical in the bottom by multiplying it by itself. And so I multiply the top and the bottom by 12. Now on the top, I get 3 times the square root of 12. On the bottom, when I multiply square root of 12 times square root of 12, I get square root of 144, which is just 12. Now, if I look at my fraction, notice I have this 3 on the outside and the 12 on the outside. These numbers can reduce. So 3 over 12 reduces to 1 over 4. And then the other thing I need to notice here is that the square root of 12 can be broken down. 12 can be broken into 4 times 3. And so from there, the 4 is a perfect square. It comes to the outside as 2 square roots of 3 over 4. And then again, I have 2 and 4 on the outside. 2 over 4 reduces down to 1 over 2. And so we get a final answer of square root of 3 over 2. So with that, you should be able to perform the process on your worksheet. So you can get the worksheet from class or on Google Classroom. Make sure to ask questions or email or check the answer key as it becomes available to try to help you complete that and make sure it's done in time to turn in.